Hola! Good afternoon, welcome, how are you? Good morning, good day, whatever it is for you. Uh, Today's video is called Using Trig Information. And so, hopefully by the time we're done, you'll have the ability to use some trig information. We're going to start with, again, should be a review topic, but it's the special right triangles. Special right triangles, we've got a right angle. Okay, we used to call this a 30, 60, 90 triangle. Now we're going to call it a pi over 3, pi over 6 right triangle. And the way this one works, it's set up so that this side is 1, this side is 2, this side is the square root of 3. They're in that ratio. If this was 10, that would be 20. This would be root 3 times 10, or 10 root 3 sort of thing. Okay, so there's that proportionality that goes on. If you have that special right triangle, you can find the sine of pi over 3. You can find the cosine of pi over 3. And you can find the tangent of pi over 3. Okay, those are really lousy 3's and pi's, but let's see if we can fix those. We just would use our SOHCAHTOA, so sine is the opposite over the hypotenuse, so the opposite side from my pi over 3 is root 3, and the hypotenuse is 2, so the sine of pi over 3 is root 3 over 2. And we just leave it at that. Don't need to change it into a number. They're irrational numbers. Let's leave them irrational. The cosine is the adjacent over the hypotenuse, so adjacent over hypotenuse is 1/2. The tangent is the opposite over the adjacent, which is just going to be root 3 over 1, and we won't bother with the over 1. Okay. Similarly, we can find the sine, cosine, and tangent of pi over 6, the other angle. Right there. So the sine of pi over 6 is going to be the opposite over the hypotenuse, which is going to be 1/2. The cosine of pi over 6 is going to be the adjacent over the hypotenuse, so it's root 3 over 2. And the tangent is going to be the opposite over the adjacent, which is 1 over root 3. We don't tend to leave things like 1 over the square root of 3. We don't like to divide by an irrational number. It's just one of those math conventions. So what we do is we multiply by 1. And the way that we multiply by 1 in this case is the square root of 3 over the square root of 3, which is 1, right? And so we're left with the square root of 3 on the top, and on the bottom, the square root of 9, which is 3. So the tangent of pi over 6 is typically expressed as root 3 over 3. What you may notice is the numbers are the same. The sine of pi over 3 is the same as the cosine of pi over 6. The sine of pi over 6 is the same as the cosine of pi over 3. Okay, the co actually has something to do with complementary. These two are complementary angles, so the sine of an angle is the same as the cosine of its complement. So, special right triangles, there's one piece. The other special right triangle is our good friend, the 1, 1 square root of 2 root triangle, which has got pi over 4's all over the place. So the sine of pi over 4 and the cosine of pi over 4 and the tangent of pi over 4, we can easily get. The sine is the opposite over the hypotenuse, so that's 1 over the square root of 2, which we're going to rationalize by multiplying by 1. In this case, the 1 is this. Okay? And so we're left with the square root of 2 on the top, and the bottom the square root of 4, which is 2. Cosine is going to turn out to be the same thing. Adjacent over hypotenuse, 1 over the square root of 2, so we'll simplify that to root 2 over 2. Tangent, well, it's the sine divided by the cosine, if you like. This divided by itself is 1, or if you want to use opposite over adjacent, you get that there. So we've got those little pieces right there. Okay, we want to be able to look at the sine curve and the cosine curve and notice that they have some sort of systematic pattern to them. Okay, this one goes up from 0 to 1, and then it goes down at the same rate. Okay, so there's some symmetry in this piece, so that the sine as we go on this side is the same as the sine going on that side. Okay, then when we get into this area, after pi, the second half of the piece, we go down, and then we come back up at the same rate. And so the sine of this and the sine of that are going to be the same, but they're also going to be the same number-wise as these two pieces up here. So we'll use the symmetry, the kind of the pattern of the sine curve and the cosine curve to our advantage. Okay, so like, where this is going to be positive some number, down here we're going to get negative the same number. That's going to be the same, and then we're going to be back to there. So there's that cyclic nature that'll help us figure things out. And that leads us to reference angles. Okay, if we have an angle in quadrant 1, we'll call it theta. Okay, that's my angle in quadrant 1. Typically, we might say that this is x, and this is y, and this is r. Okay. Of those, in this first quadrant, x, y, and r are all positive. Okay? The sine is just going to be y over r. The cosine is going to be x over r. The tangent's y over x. They're all three positive. So in the first quadrant, all my angles, all my trig functions, are positive. Okay? Not a lot of news there. If I draw an angle in the second quadrant, see if I can make that match up with the arrow. Not bad. Okay? Here's my angle. We don't necessarily want to worry about this large portion of the angle. What we look at is this piece right here, which we're going to call my reference angle. Okay? All the way around is 180 degrees. All the way to here is theta degrees. So my reference angle is 180 minus theta, or 2 pi minus theta, probably should do. Okay? Okay, or 2 pi minus theta. So that's how I get the reference angle there. If I'm in this quadrant, okay, there's my, this is x, and this is y, and that's r. R is always positive because it's sort of measured as a distance. Y is positive. So my sine is going to be positive, y divided by r, right? Y over r is going to be positive. My cosine is x over r, and x is negative because we're in the second quadrant, so x over r is negative, and my tangent is y over x, and y over x is negative. So the only thing positive in the second quadrant is the sine. Let's move to the third quadrant. Here's my angle. Okay, there we go. That's theta. This little piece is my reference angle. We always make our reference angles relative to the x-axis. So if I'm trying to find my reference angle in this case is going to be theta minus 180, or theta minus 2 pi. Okay? And so that's how we figure out my reference angle. Let's just go on to the part where we talk about which ones are positive or negative. All right, in this case, there's my y, there's my x, and there's my r. R is always positive. That's an x. And in this case, if I do y over r, that's going to be a negative divided by a positive, so that's going to be negative. If I do x over r, that's my cosine, that's going to be negative. If I do y over x, that's going to be positive. Okay, I'm just looking at the ratios. So in the third quadrant, the tangent is the only positive thing that we have going for us. Okay? And finally, let's make an angle in the fourth quadrant. There it is. There's theta. Okay, right there. Here's my reference angle. Again, relative to that x-axis, my reference angle. So in this case, my reference angle is 360 minus theta. Okay? Did I say 2 pi back here? Oh my goodness. Pi. Did I do that back here too? Oh. Bad, Mr. Trig. Fix that, would you? Bad, bad. Alright, so 360 minus theta, or 2 pi minus theta. Okay? So in this third quadrant, you might be able to have sensed a pattern. X is positive, y is negative, r is always positive. So the only one that's going to be positive in the fourth quadrant is my cosine. Okay? So the way we remember that, the first quadrant they're all positive. In the second quadrant the sine is positive. Third quadrant tangent. Fourth quadrant cosine. Okay, some people might remember it with all students take calculus or caution or Columbus Day off, something like that. So all students take calculus, gives us an idea of which one's positive, negative in the first, second, third, and fourth quadrant. What does it all mean? That's the $64,000 question. So what does it all mean? It means that if I have a pi over 3 angle right here, it's the same as a pi over 3 angle over here. And that's the same as a pi over 3 angle down here. And that's the same as the pi over 3 angle down here. This first quadrant just represents a pi over 3 angle. Okay, if I'm going all the way around to the second quadrant, let's get a different color pen. Okay, then really my big angle is 2 pi over 3. Okay, and then if I go around to the third quadrant, this becomes a 4 pi over 3. And if I go to the terrible, this angle right here, that becomes a 5 pi. 5. Let's see. 6, 7. 2 pi. Yeah, 5 pi. 5 pi over 3. Okay? So that's the way that works out. And so when we know that, I can then figure out, if I know what the sine of pi over 3 is, I can figure out what the sine of 2 pi over 3 is, because I know its reference angle is this one here. If I know what the sine of pi over 3 is, I can figure out what a 5 pi over 3 and what a 4 pi over 3 is. I can get all those angles just for knowing the information from that right triangle. Okay? So we're going to do hand trig, and I'm going to switch over to the hover cam. And look, there's a hand. Let's see if I can make this work for you. So what I've done is I've traced a hand, my hand actually, and with that tracing, there's a little something that you can do. This is the right hand, okay? And what you want to realize is that, or the way we set this up to help us remember some of the things, is this is 0, this is pi over 6, this is pi over 4, this is pi over 3, and this is pi over 2. All right? Inside the hand I've got 0, square root of 1, square root of 2, square root of 3, square root of 4. Okay? And in my hand, I've got over 2. Okay? If I want to know what the sine of pi over 6 is, sine of pi over 6, square root of 1 over 2. What's the square root of 1? 1. Okay? Sine of pi over 6 is the square root of 1, which is 1 over 2. If I want to know what the sine of pi over 3 is, sine of pi over 3, go over to this part of my hand, root 3 over 2. Sine pi over 3 is root 3 over 2. What is that? How about root 3 over 2? Better. Okay? If I want to do the cosines, the part inside the hand stays the same, but I start with 0 over here, and then I go to pi over 6, and then I go to pi over 4, and then I go to pi over 3, and then I go to pi over 2. Okay? Pi over, I can do this, pi over 2. If I look at that, the cosine of, if I want to know the cosine of pi over 2, cosine of pi over 2 is 0 over the square root of 2, which is 0. Okay? Cosine pi over 2 is 0 over the square over 2, which is 0. Okay? So that's something to play with. Okay? You start with 0, pi over 6, the smallest fraction, the next smallest fraction, the next smallest fraction. You work your way through the main ones that we deal with. 0, square root of 1, square root of 2, square root of 3, square root of 4. Everything's over 2 in your hand. Okay? It's called hand trig. Some people find it handy. Some people don't. If it works for you, we want you to know about it. Okay? Alright, back to our story here. That's hand trig. A couple of them for you to try. So let's see if you can find the sine of 4 pi over 3. So here's what we need to know. I'll walk through this one and I'll leave you a couple to do by yourself. The sine of 4 pi over 3. It's an over 3 one, so it's going to be based on my right triangle with the, the 1, 2, root 3 thing. Okay? And the pi over 3 is down here. 4th pi over 3, what quadrant are we in? Okay, we're over full, so we're in the 3rd quadrant, right? 3rd quadrant. Is my sign positive or negative? Sign is negative. So then I'm just worried about, well, what's the sine of pi over 3? Sine of pi over 3, opposite over hypotenuse, root 3 over 2. So it's negative root 3 over 2. If I asked you to find the cosine of 7 pi over 6, okay, same triangle, but now we're using this one. Okay, cosine 7 pi over 6. Cosine is adjacent over hypotenuse, so we're looking at a root 3 over 2. Where are we when we're at 7 pi over 6? Well, let's see, we're again, looks like we're a little bit over 1, right? 7, 6, there's more than 1, but not quite to 2, so we're in this quadrant still. So again, we're negative. Last one I'll leave you for is the tangent of 5 pi over 4. See if you can come up with that. We'll talk about it when we talk about it. And that's about all. I've gone, I think, really long. Let's see where we are, 14:51. I got 9 seconds to wrap up. So the way I'm going to wrap it up is to say thanks for watching, and We'll talk to you soon. Hope you learned something.